Hey kids and adults and anybody else watching this crazy video. By the way, this is Common Core Test Practice Test 3. This stuff can be found at www.nkinfinity.com. Anyway, I had a couple mistakes in part 1. I apologize. We're doing the best we can. I apologize. Don't hurt me. Anyway, we're going to get started. Let's just move. All that stuff can be found there. All right, let's go. Here we go. In Arlington, New York, the heights and the population of girls are normally distributed with a mean of 63 and a standard deviation of 2. And I have 450 girls. Determine how many girls are shorter than 60. All right. You always should draw a picture. It makes your math teacher happy. Standard deviation of 2. I don't care about that. We just want to get lower than 60. So that's down here. Normally I'd find a z-score. I go 60 minus 63 over 2. And I'd get what? Negative 3/2 or negative 1.5 standard deviations, which I probably could use my table, but they don't give us a table. So I'll go into my z-score table. Oh no, don't give me a z-score table either. So I have to use my calculator. So you need to explain to your the user that we're going to use used calculator, normal CDF, with a min of negative infinity, a max of 60, a mu of 63. I probably should have called this mu because it didn't say it was a sample. It just said it was the average. And my standard deviation is 2. So we go over to your calculator. You go into calculate mode. Let me get rid of all the crap from before. And you go into menu 552. Normal CDF, negative infinity. Now, if your calculator doesn't do negative infinity, it probably has this right now in there. Negative, and you could just put in a bunch of 9s. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, forever and ever and ever and ever and ever and ever. All right, maximum's going to be 60. The mean is 63, and the standard deviation is 2. Click OK. So I get a, now don't round this, okay? So the probability that x is less than or equal to 60 is equal to you cannot round this, 66807, 66807, 22872, 22872. Now that is a probability. So what I can do with that is say, hey, now we got 450. Somehow I forgot the 450 girls. So I'm going to take that number, 450, and simply multiply it by 0.668072287. And so I'll just take this, multiply it by 450, and I get 30.06. So 30.06, rounded to the nearest integer. Okay, so there are 30 girls less than 60 inches tall. Ka-ching, done. All right, the table below shows the concentrations of ozone in the Earth's atmosphere at different altitudes. Write a regression equation that models to the nearest hundredth. Now, write a linear regression? No. Write a exponential? I don't know. Okay, so again, how do I know? I don't know. There's no way to do this without punching this stuff in and getting a look at it graphically. So we're going to go look at our graphing calculator, go into calculator mode, call this X, I guess, call this Y. I'm going to look down while I put these numbers in. 0, 5, 10, okay, 0, 5, 10, 15, and 20. 0.7, 0.6, 1.1, 3.0 and 4.9. Now, just looking at them, I'm already getting a sense what it's going to be. But, you know, I don't know. So I can go through and do all kinds of different regression models, but until I get an idea what this looks like, I'm not going to be able to do it. So we're going to go into Doc, Insert. Something happened. Doc, Insert. Oh, crap. Menu. Insert, data and statistics. All right, click add a value, click X here, click Y here. And now I can see this is not linear. This is going to be exponential growth. Even though this one came down, it's still exponential growth. You see how high it's fast it's growing? Right? See how it's growing really fast. So this will be exponential regression. So the first thing I'm going to do is state its exponential regression. So now I can go back and I can go, okay, go back to this tab, go Menu, Statistics, Stat Calculations, and Exponential Regression. Doesn't like when I do it that way. Menu, Statistics, Stat Calculations, Exponential Regression. I got an X list, I got a Y list. I click OK. And remember, this is my equation. Y equals. Most kids will forget that Y equals in order to get the equations. A times B to the X. So A equals 0.488156. 0.488156. I always say 6 decimals will keep you out of trouble. 1.11630. 1.16306. All right, so rounded to the nearest thousands place. Let me go highlight that. Thousands place is 3 decimals. So it looks like we're not going to change either of those. So it's Y equals 0.488 1.116 to the X. If you forgot the Y equals, it's wrong, kiddos. Yes. Moving on. All right, I'll do this one real quick. Convert from radians to degrees. Now, let me see if I can get to your formula sheet. I think they're here. Wait, I have it here. There's your formula sheet. And let's maximize this. So 1 degree is equal to pi over, but I have radians, right? So I have radians. We're going to convert radians. So 1 radian is equal to pi over 180. Now don't set up a proportion. We're going to just, where am I going? Oh, I think I'm in this one. So what we're going to do is we're going to take 2.5, and 1 radian is equal to, what did I say it was? Pi over 180? Pi over 180, right? So we're going to multiply by 180 over pi. What am I saying? Let me go back. Highlight it. There it is. 180 over pi. All right. And we'll get some value. I don't know what it is. Let's go. They want it rounded in nearest minute, so we're going to have to go calculator mode. What was it? I forgot what it was. 2.3 or 2.5? 2.5 times control division 180 over pi. So 143.2389. So this is 143.23944, But they said to the nearest minute. So you have to DMS this. It does not stand for Doug Miller Soccer. It's DMS. So you go into your catalog book, and if you don't have DMS there, you just scroll down until you find DMS. It stands for degrees, minutes, seconds. Click enter. So you DMS it. 143.14. Now, if I was writing this problem, I would have made it harder. 143 degrees, 14 minutes. Now, and it's 22 seconds. I'm going to put that on there. The cutoff here is 30. If that was over 30, this would make this 15. But as it stands, it's 143, 14 minutes. All right, I'll be back. All right, so a couple vocabulary words, or a vocabulary word here, and that's this word conjugate. The conjugate of this thing is the exact same thing. That's the original. But you multiply by the conjugate, which is the exact same thing, but with a minus. They probably should have told you that I is the imaginary number and not a variable. That would have been better. So x times x is x squared. X times negative y is negative y, negative xyi, and these are positive xyi, and then minus yi squared. All right, so these cancel because they're the exact same thing. Now you need to remember, kids, that I squared is really negative 1. So instead of negative y times negative 1, this is really positive y. So x squared plus y squared. Now, if I were you, what I would do in this case is I would, let me show you this because I don't think you guys believe me. Some of you don't believe me. I'm going to take two obscure numbers like 2.3 and store it in for x, and 3.5 and store it in for y. And then type in the original. Now, you do need to still know what conjugate is. So x plus y times I. It doesn't like when I do that. I, parenthesis, parenthesis, x minus y times I. And you press enter. It gives you that. Some weird number. Okay, well, what did we come up with? We came up with x squared plus y squared. Wasn't that what we came up with? Oh, look, it's the exact same thing. 100% got it right. Star it. Don't ever have to look at it. Anytime you can use your calculator to check a problem, star it so you never have to look at it again. All right, in order to solve an exponential equation, you need to convert it to a logarithmic equation. You need to use its inverse function, which is exponential. All right, so you need to turn this into exponential. And I don't know if you heard or not, but it's all about that base, about that base, about that base, all about that base. I made a video, me and my partner in crime. It was sick. It went viral. Nah, not one bit, man. It's awful, but we looked good. Oh, you want to see it? Hold on, I'll bring it up. All right, I found it. Oh, I forgot to press play. This is my partner in crime, Miss Newman. I don't know. Was it playing? Oh, I look pregnant in this thing. It's a really bad thing. Oh, wait. Oh, yeah, baby. We're singing. We're sick. A little car karaoke from some two lame math teachers. That's some crazy singing there, baby. Woo, man. Cover your ears. That's awful. But it is all about that base. In this case, the base is 5x minus 1. So my base is 5x minus 1 to this exponent, to the 1/3 power, is equal to 4. So that's the first hard part about this problem. Now, hard is relative term. So now the difficult part is I want to get rid of that 1/3 exponent. So the easiest way to get rid of a rational exponent is just to raise it to the reciprocal. Raise it, not multiply, raise it to the reciprocal. So I'm going to cube both sides. Well, when you cube it or when you raise it, you multiply those. So they kind of just cancel each other out. I get 5x minus 1 equals, and this is 64. Add 1 to both sides, I get 5x equals 65. Divide by 5, and I get x equals 13. I hope you all enjoyed that problem. That's a 13, by the way. It is. It's a 13. All right, as you went through the trig unit, did you not see a lot of 1/2 square roots of 3, 1/2 square roots of 3, 1/2 square root of 1/2 square root of 3 over 2, 1/2 square root of 3 over 2, 1/2? You saw it all the time. Saw it all the time. So, we got a circle in standard position. Those are both positive, so it's going to be somewhere in here in the first quadrant. We'll draw it a little bit more accurately. It's actually right here. It's on the unit circle. If it's on the unit circle, 1/2, comma, square root of 3 over 2, then if it's on the unit circle, then the x value is actually cosine. That's cosine. This would be sine. So I know that the cosine of theta is equal to 1/2 because it's on the unit circle. I know that. And I need to then remember, oh yes, cosecant theta is equal to 1 over cosine theta, or secant theta is equal to 1 over 1/2. Well, that's kind of silly. If you just remember that secant is the reciprocal function of cosine, then this is just 2. And that's your answer. That was a very simple question, but you had to remember some things. All right, let's get to a really easy one. I'll use this pen. So not that too much. So what I want to do, I got this point, I got this point, and this point, and this point, and this point. Looks like I got a point here, and I got a point here. And what we're going to do is we're going to transform this thing by moving this to the, not right, left 2. Remember, it's backwards, and up 1. Remember, this is backwards, this is normal. So we're going to move it left 2, 1, 2, up 1. Better pick a different color. Left 2, up 1. 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 Close. Close. That's it. That's all she wrote for that one. I don't know. That was kind of simple. Left 1, up 2. Just a quick transformation. By the way, if they ask you to write the equation of this, you can write this equation. Let's call it g of x. G of x. And it's equal to x. Now we went minus 2, so plus 2 squared, and then down 3, minus 3. Now, I also, because I went to the right 1 and up 1, there is no transformation, and it's going up, so it's positive. So that actually is the equation of that, that new transform function, just in case they ask. They won't, but they might. Inverses, inverses, inverses. Step 1. Switch x and y. Switch x and y. So we're going to switch x and y. What's y? This is y. So x is equal to y minus 3 cubed plus 1. All right. So I got to get this weird thing alone. Here's my weird thing. So I'm going to bring the 1 over. I get x minus 1 equals y minus 3 cubed. Now, once again, in order to get rid of that cube, I'm going to raise it to the reciprocal, 1/3. Raise it to the reciprocal, 1/3. So, how do I do that? Well, okay, let's see. This is just x minus 1 to the 1/3 power is equal to y minus 3. Now, I just got to bring this over. So, I get x minus 1 to the 1/3 power plus 3 equals y. So, f inverse of x is equal to x minus 1 to the 1/3 power plus 3. Now, if you don't like that, by the way, you definitely should have inverse notation because that's what it told you to find this. You should write it professionally. If you don't like this, you could also have this answer. You also could have, at this step, let me show you. Because some of you did this. Instead of raising it to the reciprocal, you took the cube root. And it's the exact same thing, because doesn't 1/3 power mean cube root? So you end up with the cube root of x minus 1 equals y minus 3, and then you bring the 3 over. So your other acceptable answer is cube root of x minus 1 plus 3. Either one of these would be full credit. So you see where it says here, solve this algebraically. Okay, let's solve it algebraically. X cubed plus 5x squared minus 4x minus 20 equals 0. Nope, I don't want to do it algebraically. I'm cheating. We're going graphically. Graphically. So it's x cubed. So x cubed, get out of cube mode, plus 5x squared, plus 5x squared. Oh yeah, I'm a badass, man. I'm just skipping. I'm not even, the heck you to you, New York. I'm just going to do it this way. I'm doing it this way, and you can't stop me. Blah, 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 blah. There are my answers, kids. -5, -2, and 2. So I know what my answers are. -5, -2, and 2. Yay! What, you want the other way? I know you want the other way, and that looks like crap, so let me fix it. I know you want the other way, but why not start with the answers? You can, I know we're going to do it algebraically, but why not start with the answers? All right, now let's go back to working on it. What can I take out of these two? I can take out an x squared, and I'm left with x plus 5. What can I take out? I always copy over the sign. What can I take over these? I take out a -4, and I'm left with x plus 5. Don't forget, these parentheses have to match. Well, my first set of parentheses is x plus 5. My second set is x squared minus 4 equals 0. I'm going to factor the x squared minus 4, x plus 5, x squared, excuse me, x plus 2. It's the difference of two squares, x minus 2. And my three answers are x equals -5, x equals -2, x equals +2, which, just in case you're wondering, we already knew. But why not start with the answers? That way, if you make a dumb mistake, you can see, I can find out where I made my mistake, maybe. Or you realize you made a mistake instead of giving me crazy answers. All right, according to the Census Bureau, the probability that there's a part of this question I'm not exactly happy with, but it's okay. It's not bad. Probability of random selected males is 65 or older, so the probability that a male is over 65 is equal to 0.114. And the probability that a female 65 or older, probability of female greater than 65, is equal to 0.146. Apparently women live longer. If they are randomly selected, what is the probability that both of, so is the, I hate to ask this question, is the probability of being male and the probability of being female independent, right? Is being female have any effect on being male? I'm going to say no. I'm just going to go there and say no. So therefore, I'm going to say that they're independent. So this is the probability of male over 65 and female over 65. So therefore, they are in fact independent. This isn't my favorite question, by the way. So I'm going to say that's the probability of male times the probability of female. So this is equal to 0.114 times 0.146. I don't know why I brought that up. 0.114 times 0.146 equals 0.0166. 0.016644. It's at rounded a thousandths place. Let me highlight that thousandths place for you. That's this one. So we're going to round it. So the answer is 0.017. There it is. That's the probability. Now, it did not say percent. It said probability, which means you leave it as a decimal. If two females are selected around the probability that neither of them is 65. Well, this is the probability of not female over 65 and the probability of not female over 65. Now, theoretically, by taking out that one, you sort of reduce the probability, but not really. So what is the probability of not being female? So we got to figure out what that is. It's 1 minus 0.46. So not female over 65 is equal to 1 minus 0.146. So let's figure out what that is. 1 minus 0.146 equals 0.854. So this is really equal to 0.854 squared times itself. Let's just square it. Done with this problem. 0.72936. 0.72936. Round to the nearest thousandths place. We're not going to round it. It's just 0.729. Not my favorite question. I think there's a few flaws in it, but hopefully you get the idea of what's going on with that problem. So, oh my goodness. So we haven't seen one like this in a while. Holy mackerel. Okay, that's not a problem. So this is a parabola. Now if you type this in your calculator, which I am not going to do, x squared. So we're going to do x and x squared, the part of that. I got to plug in less than 1. So how about we start with like -3, -2, -1, 0, and 1. I can't go over 1. And remember, this is going to be an open circle. So -3 squared is 9, 4, 1, 0, and 1. So if I graph this, 1, 1 is going to have an open circle on it because notice there's no equal to on that part, right? So 0, 0, 1, 1, -1, 1, -2, 4, -3, 9. I'm hoping those are right. I didn't count. Hopefully there's 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. All right. So that's that. Now this is a linear function. So this is going to be x and 1/2 x plus 1/2. So I'm going to plug in. This is for x is greater than 1. So I'll plug in 1, 2, 3, 4. Now wait a second. Since these are all halves, I don't know, 5. I'm not really happy about this. Let me do this though. Well, if I plug in 1, I get 1. If I plug in 2, I get something annoying. If I plug in 3, I get, well, we could just do this on our calculator. Quite honestly, I would just put, here's what I would do on this one. I would just put the y-intercept is here, go up 1 over 2, up 1 over 2, up 1 over 2, and be done with it. But what I'm going to do, oh crap, there's an open circle there. For you guys, what you probably would do is just go into graph mode, go into graph mode, and you know, you could graph x squared. There's x squared. And then you can graph tab 0.5x plus 0.5. And there's that one. And notice they hit right here at 1, 0. And I can go to the table, Control T, and just look up in the, oops. Escape, escape. Control T. Come on, let me get there. And look up the magenta ones right here. 1, 1, 3, 2, 5, 3. So on and so forth. 1. So we're going to have that open circle. 3, 2, 5, 3, so on and so forth. So that's going to look like this. So that's graphing the piecewise function. Okay, graphing. Now we're going to graph. Now we're going to do this. Now, this part, this is a 4-point question. This part was relatively simple, straightforward. Plug it in, graph the points, make sure you left an open circle. This, however, is a little nasty. So g of x, let's do it in red first. G of x is going to be equal to 2 times f of x minus 3 plus 1. Now, f of x minus 3 has 2 parts. If I take the first part, which is f of x minus 3, which is equal to x squared, right? What we need to do is you see, oh, plug this in for x squared. So you get f of x minus 3 is equal to, I probably should, whatever, x minus 3 squared. Okay, so this one's not too bad. If this is my now, this is really f of x minus 3. So if I take this and I plug it in here for this, the first part, part 1, is going to be 2 times x minus 3 squared plus 1. That was the easy part. And this is for x is greater than 1. Next part's a little, actually, it's a ton nastier. The other part of the equation was f of x is equal to 1/2 x plus 1/2. I'm going to do f of x minus 3. So this is equal to 1/2 times x minus 3 plus 1/2. Now this piece is now going to go in for this. So this part 2 is going to be 2 times 1/2 x minus 3 plus 1/2 plus 1. So if I distribute 2 times here and then 2 times here, these cancel and I end up with just x minus 3. 2 times 1 is 1. Actually, this 2 times 1 doesn't cancel. They make 1. And then 1 times this. And then 2 times 1/2 is plus 1. And then another plus 1 here on the outside. Don't forget that. So I end up with x minus 1 as piece 2. But you're not done yet. You got to write it in a piecewise function. So g of x is equal to 2x minus 3 squared plus 1 for x greater than 1, and then x minus 1 for x less than 1. Oh, wait, I think I said that wrong. I think I got the domain wrong. The first one has less than, the second one has greater than. I just got the domains wrong. So yeah, right there, I did all that good work and I made a stupid mistake. So this should be x minus 1. This is for x less than 1. This is for x greater than 1. All right? And then that's actually the part answered. That was not an easy question. That was not an easy question. If you got that one right, nice job. All right, so it says we're going to use the formula below to do a 7-year car loan. Start highlighting some of this. 7-year car loan, an interest rate of 1.1%. Be careful of that. We've got the original cost of the loan is this, and we're going to down payment this. So, borrowed. How much am I going to borrow? If the original price of the car was $25,750, and I put a down payment of $22,300, then I really only have to borrow $23,450. So that's how much I'm borrowing. That's the $450. The number of payments, well, monthly payments, and I'm doing it for 7 years, so I got to be careful. It's 7 times 12, which is 84 months. Every time I write a 4. This I don't know, and my interest rate is 1.1%, but again, that's really 0.011. Just be really careful with those percentages. All right, so how much am I borrowing? I'm borrowing $23,450. I don't know what my payment's going to be. All right, but I know the rest of this. It's 1 minus 1 plus 0.011 to the negative 84. Notice there's a negative there. Hey, I made a 4 right. All over 0.011. So that behemoth thing on the right, I'm going to put in my calculator. Just going to look down. It's control division. Wait, I need parentheses too. Actually, I really don't, but I'm going to put them in there anyway. So 1 minus parentheses 1 plus 0.011. Careful where you put the raising to the negative 84 all over 0.011. Now, you should get partial credit, so I'm going to write this down. I'm going to actually write this step down. 23,450 equals my payment times 53 point, don't round, do not round, 6422. Do not get lazy, 06743. Now I'm going to divide by that. I thought it was 54. See, it's 54. 54. Divide by 54.642206,743. Divide by 54.642206,743. The reason you want to show this work is because you're showing in between correct parts of the problem. And if you get those right, but you maybe missed the final answer, 23,450 divided by, now I would never type that in. Hit the up arrow, highlight it, hit the down arrow, boom. 429,155, so 429.15543. Now my guess is we're going to round this to money, but I'm not sure. Round to the nearest penny. Now penny is 2 decimal places. Now if you did all that work and wrote $429.15, you'd be wrong. It's 16 cents. Man, you know, get all that great work and then you screw up a point there because of that. The affordable monthly payment is only $325. So clearly I can't afford $429. So then the car dealer is going to come back and say, okay, you need a bigger down payment. All right. I don't know what my down payment's going to be. So I don't know what my amount paid at 84 months is going to be. But I do know I'm going to do $325. Now the cool thing about this is I've got our list mostly already done. 1 minus 1 plus 0.011 to the negative 84 all over 0.011. Well, this is already stored in my calculator, so I'm just going to use that to my advantage. 325 times, well, it's really this, right? Equals 17,700, so P84. This is how much I can borrow for 84 months. 17,758, 17,758. Got to get the money, right? 1717, so it's really 72 cents. So the original cost of the car was $25,750. This is all I can afford. So minus $17,758.72. So 25,750 minus, and then I'm going to make it 2. So my down payment has to be $7,991.28. Round to the nearest pen. Oh, man. Nasty. Nasty, nasty, nasty. Round to the nearest dollar. All of a sudden they decide to change it. We're putting these a lot on your practice tests so that you just get really conscious of always reading that. Newman and I did this on purpose to do this. Now saying that we did that on purpose, I guarantee we did that on purpose. But if you look at the answer key, her answer key says this. Or the answer key we put up says this. This is not correct. It has to be no pennies. Be careful of where they ask you to round to. It's always going to trick you, and it just tricked us. So this was a complicated question, actually on an old trig Regents that we pulled up, but it kind of deals with the kind of weird stuff that Common Core is asking. So we thought, what the heck, let's put it back on. It's a lot of reading, it's a lot of understanding, but it's not an overly difficult problem. As soon as you see ln, you see this ln right here? As soon as you see this ln thing right here, there's almost a guarantee that you're going to be using the exponential base e in order to solve it. It's almost always going to happen. Okay, so let's see if we can understand what's going on. T0, this is room temperature. T is in minutes. K is just some constant. Just some constant. And what's T? This T is the temp of chocolate. Ooh, chocolate. So a cup of hot chocolate is placed in a room with a temperature of 68 degrees. So my T0 is 68 degrees. After 3 minutes, my time is 3 minutes. Now wait, let's make sure, is time in minutes? Yep, time's in minutes. You got to be careful. Maybe it was seconds. I don't know. Again, watch your units. And the hot chocolate, or T, is equal to 150 degrees. Okay, so compute the value of K to the nearest thousandth. All right, so all we got to do is type this stuff in. The ln of 150 minus 68 is equal to negative K times 3 plus 4.718. So the first thing I'm going to do is I'm going to bring this 4.718 over and minus 4.718. But I'm going to do this work in my calculator. So the natural log of 150 minus 68, and then it's minus 4.718. And I get, I'm going to write this down, negative 0.311. Do not round 2807. 527, that should be enough. 527 is equal to negative K times 3. Now we're just going to divide by 3. Actually, I'm going to divide by negative 3. Because there's a negative here too, and that'll give me K by myself. So I'm going to divide by negative 3. Oops. I'm going to divide by negative 3. And I get 0.107, so K is equal to 0.107, oops, 1037, careful with that, 1037, 602. And they want us to round to the thousandths place. And again, highlight that thousandths place if you want. I want to highlight this. So that's going to round up. So K is equal to 0.104. Don't make the grader look for your work. Don't make the grader look for your answer is what I mean, 104. So now using the K value found. Now let's say you couldn't find K. Let's just say you couldn't find K. Make sure I'm going to set K equal to 2. If you couldn't find K here, you know, take the second part and say, I'm just going to make K equal to 2. Anytime it says using your previous answer and you couldn't find the previous answer, just make up a number and keep going. Don't quit. Do not quit. I know that sounds stupid. Don't quit because you still can get quite a bit of credit. All right. Using this value of K, find the temperature T of this cup of hot chocolate after it's been sitting in there for 10 minutes. All right, so the natural log of T minus T0, the room temperature is still 68 degrees, is equal to negative K, negative 0.104 times 10 plus 4.718. All right, so I just plugged in all the information in that calculator. So I'm going to figure out what this crap is because it's all numbers. So let's figure out what that is real quick. So negative 0.104 times 10 plus 4.718 equals 3.678 equals the natural log of T minus 68. Now, I did tell you a couple of seconds ago, as soon as I saw that ln, I'm probably going to be using E, right? Because the only way to solve a logarithm is to use exponential, and it's all about that base, Now, There is no apparent base in this problem, which is what drove my kids crazy the year they did this. There is no apparent base, but there actually is a base. Remember, the base on any natural logarithm is a phantom e sitting right here that you have to remember is there. That's why I knew I was going to be using that e. And since it's all about that base, I can bring up the video. I mean, if I have to, I think it's still there.
This song's about booty? I think so. No, it's about math. I thought it was about math too. I've been playing this for years in my math class. I thought it was about bases of exponents and logarithms. Of course it is. Of course it is. It's about bases and exponents. Megan Trainor must not know what she's doing.
Yeah, no, she didn't.
We should let her know.
We should. I told her.
We'll do that.
I told her. She didn't believe me. Can't believe it. I thought it was about bases and logarithms. It's not. It was my debut. It was awesome. Anyway, I know it was bad, but it was okay. We're going to do E. Now we're going to switch sides to the 3.678. We're going to do change of base is equal to t minus 68. You changed a logarithm into an exponential function, and it's all about that there base. So now I just have to add 68, and I'm done. So I come over here to my calculator, and I go E raised to the answer that I just came up with, and I'm going to add 68 degrees. And I get 107.56. So T equals 107.56. 718. What does it round it to? What do we want to round to? Round it to the nearest degree. T is equal to 108 degrees. Circle it, done. Ladies and gentlemen, practice test 3 is finally over with, and I can finish drinking my coffee. Oh my God. Search Kendrick Krause, all about that base. You'll find that amazing video. Send it to your friends. I want it to go viral. Hit the subscribe button. Hit the like button. Glad you stuck with me. Keep working hard. It pays off, kids. It pays off. I had a kid the other day goes, well, I took a test today, and 2 of the questions that were very much like the one you gave us. Is that like cheating? And I'm like, no, that's studying. When you walk in and you've seen those equations before and you know what to do, that's studying. All right, kids, keep working hard. I got to go work in the garden.